Good day, sir. My name is Choo Jia Qi, and in this video, I will demonstrate the use of statistical programming with R to analyze a sleep efficiency dataset and perform correlation and multiple linear regression. To begin, I conducted the Shapiro word test to check the normality of the data using the Shapiro.test function. And now we run the code. The test produces a W statistic and a p-value to interpret the result. If the p-value is greater than 0.05, the data is considered normally distributed. However, if the p-value is less than 0.05, the null hypothesis is rejected, indicating that the data does not follow a normal distribution. In our analysis, all variables return p-value less than 0.05, as most of them return 2.2 exponent negative 16, suggesting that the data is not normally distributed. The result is expected as the dataset was not collected personally and likely come from various sources. A correlation analysis was performed to evaluate the relationship between various factors and sleep efficiency by using the core.test function. The significance of each correlation was determined by comparing its p-value against a threshold of 0.05. If the p-value was greater than 0.05, the null hypothesis was not rejected, implying no significant relationship between the variables. Conversely, if the p-value was less than 0.05, the null hypothesis was rejected, indicating a significant correlation. Now we run the code and observe some example. As we can see, the correlation between the gender and also the sleep efficiency reveal a presence of 0.01 with the p-value of 0.83. Since the p-value is greater than 0.05, the null hypothesis is not rejected, indicating that not significant correlation. This means that gender does not meaningfully influence the sleep efficiency in this dataset. In contrast, this sleep percentage show a strong positive correlation with sleep efficiency with a coefficient of 0.788 and a p-value of less than 2.2 exponent negative 16. This significant result indicate that as this sleep percentage increase, sleep efficiency also improve, confirming that this sleep percentage is a critical factor in explaining variation in sleep efficiency. Before fitting the regression model, I created a data metric using the data.metric function that was very essential to evaluate multicollinearity among the predictor using the variance inflation factor. High multicollinearity can mislead the regression result by inflating the variance of the coefficient estimate, making it challenging to determine the true relationship between predictor and the response variable. To address this, variables with a variance inflation factor exceeding 5 were identified and excluded from the model. For example, like sleep percentage was removed due to concern about multicollinearity. Moving forward, I perform a multiple linear regression analysis using the LM function and then check again the multicollinearity of the model by using the VIF function and importing the car package to ensure that there are no multicollinear variables that can mislead the result. As we can see, the results for all predictors are around 1, which implies that the coefficients in the regression model are stable and the statistical significance can be used for interpretation. After that, I use the summary function to obtain the output of the model. Square value of 0.8034 indicate that the model explains about 80.34% of the variation in sleep efficiency, showing a good fit with the data. Besides that, each estimated coefficient represents how much the sleep efficiency is expected to change with a 1 unit increase in the corresponding predictor, while keeping all other variables constant. And the equation to predict the sleep efficiency is as follows. According to the p-value, the analysis showed that predictors such as age, release percentage, deep sleep percentage, awakenings, alcohol consumption, smoking status, and also the exercise frequency are significant with p-value less than 0.05, indicating their strong influence on sleep efficiency. In contrast, gender, sleep duration, and also the caffeine consumption were non-significant. In conclusion, through correlation analysis and multiple linear regression, we examine the relationship between various factors and sleep efficiency. The regression model with an R-square value of 0.8042 demonstrates that this factor explains a significant portion of the variation in sleep efficiency. However, hypothesis testing revealed that age, awakening, alcohol consumption, smoking status, as well as exercise frequency are key predictors. The exclusion of light sleep and percentage due to multicollinearity highlight the importance of carefully selecting variable in regression model. Thank you. That's all for me.